Hi, everyone. It's Hugo Bowne-Anderson here from Outerbounds. I am more than excited to be here today with Jason Reid, head of product and co-founder at Tabular, to talk about the open source modern data stack and everything that entails. We're going to get started in a few minutes. We're just going to wait for a few more people to roll on in. So if you're able to introduce yourself in the chat on YouTube, let us know who you are, where you're calling in from, what you're up to with data science and machine learning, and what you do. That would be super awesome. All right, back in a couple. Hey everyone, it's Hugo Bowne-Anderson here from Outerbounds. Thank you so much for joining us today to chat with Jason Reid, head of product and co-founder of Tabular, about the open source modern data stack, everything that means, everything that entails, and how we can think about the data end of the entire stack to help us deliver as much business value as possible and what that means. If you can introduce yourself in the chat on YouTube, that would be fantastic, and we'll get started in a couple of minutes. And I see Carol Willing in the chat who says, howdy, Hugo. Hey, Carol, it's been a long time. And Jason, Carol's sending all the best from Notable to Jason as well.
Awesome. Love the folks at Notable, ex-Netflixers, great colleagues.
Exactly. Fantastic. All right, everyone, we'll get started in a minute. It's Hugo here from Outerbounds. And I'm super excited to be here today with Jason Reid, head of product and co-founder at Tabular, to talk about the open source modern data stack. We also have Alex Leith, who's appeared in the chat, who's here from Tasmania. And funnily, both people who've commented are both Carol and Alex. I've worked with previously on similar events to these types of live streams, actually. So that's really cool. And we also have Morley from Philadelphia. So we've got people from all around the place. Great. Well, without further ado, Jason, why don't we turn our cameras on and get started?
Sounds good.
Good morning, as I'm in Australia, and good afternoon to you, Jason, in sunny California.
It's, yep, sunny and 75 per usual here.
Okay, there you go. Good to hear. And once again, I'd just like to welcome everyone to this this fireside chat. Do introduce yourself in the chat, and feel free to ask any questions along the way as well. Just before we get started, a bit of bookkeeping. We're going to have an AMA, an async Ask Me Anything on Slack afterwards for any questions we don't get to and any more that arise. So I'm just going to paste a link to that in the YouTube chat. And for those who don't know about what we do at Metaflow and Outerbounds, we work on infrastructure and productivity tools for data scientists that allow them to focus on the top layers of the stack, on building models and doing science, while having easy access to infrastructural layers such as compute, orchestration, versioning, We do this mostly through open source Metaflow, but we're really excited to be working on products as well. So definitely check out outerbounds.com and Metaflow. And I'm also just going to paste we have Sean here from Southern California. Great. I'm just going to paste the Metaflow GitHub for those interested in checking it out. And if that's something that you're interested in, please give us a star as well. I also wanted to let you know the next event we're having in a few weeks, which I'm very excited about. And I've pasted a link to that as well on Eventbrite that you can sign up. It's an introduction to Kubernetes for data scientists and machine learning and engineers. The reason I'm excited about that is at Metaflow and Outerbounds, we don't think data scientists and MLEs should necessarily need to know too much about Kubernetes. But if they're interested, we want to make sure that they're able to. So I'm having this live stream with a Kubernetes expert from Outerbounds and Metaflow to talk about everything you need to know about Kubernetes, or that would be useful. But also we have Brian Galvin, who was at Netflix, the LA Times as well, and a number of other places. Who he started as a data analyst and statistician. And data scientists working in R and slowly moved his way to more infrastructural stuff. So we want to tell that story as well, so people have a sense of kind of the different career paths that can happen depending on your interests. So that's a little pitch for our next event for those interested. Obligatory, if you enjoy this, hit subscribe wherever that thing is and share with all your friends. But that's enough out of me. I'm super excited to be here with you today, Jason, and you're head of product and co-founder at Tabular, the company behind Apache Iceberg that powers big data at hundreds of companies. Previously, you led data engineering at Netflix as director of data architecture. So maybe you can tell us a bit about yourself and what you're up to at Tabular and Iceberg, and then we can jump in.
Sounds good. Thank you, Hugo. Very glad to be here. Thanks for the invite. Let me come on
and chat
with you about data infrastructure, something that is exciting to a few of us in the world. I'm definitely one of them. So yeah, quickly, last 2 years at Tabular, co-founded with Ryan Blue and Dan Weeks, two of my Netflix colleagues and the authors of the Apache Iceberg project. They authored originally at Netflix. Can't take much credit for writing the code, although I think it was the result of many of the requirements that I was sending their way, leading the data engineering efforts at Netflix. And we can get more into how this is related to our conversation today. But was at Netflix for 8 years, did all things data engineering and experimentation, and worked with Vile actually and the Metaflow team. They are also Netflixers, so just fantastic people, great set of technologies that obviously is behind everything that Netflix does with data, which is a ton of different stuff. I've been enjoying running product at Tabular the last couple of years, and basically trying to bring the power of that architecture that we had at Netflix to the rest of the world, other organizations that don't have 50-person data infrastructure teams running around, open sourcey things.
So we'll get to this in more detail, but for those who don't know a lot about Iceberg, maybe you can tell us a bit about Iceberg.
Yeah, absolutely. So Iceberg was technology developed at Netflix really to overcome the problems that we were having trying to run our data infrastructure based on the Hive table format, which is kind of the precursor to modern table formats, which Iceberg is one. And the goal there really is much like you talked about data scientists not having to focus on low-level infrastructure, compute, and network and these things, they let them focus on doing the data science work and the business work. A similar story for Iceberg. It's really to get data analysts and ML folks and data engineers to stop having to think about files and file formats, things like Parquet and table layouts and partitioning, and all these very low-level details, and let them up-level and just think about solving the business challenges. So Iceberg allows, that kind of abstraction, layering up that abstraction a little bit. And then the other big thing is really allowing all these different data tools in the ecosystem to play together on the same data sets safely. And that's kind of the big difference with something like Iceberg versus historically And that's a big part of, I think, what we're going to get into today. But yeah, it's like, hey, if I have a data set and that's my source of truth for whatever it is in my business, my customers, signups, payments, whatever it might be, videos watched in the case of Netflix, you want to be able to use that source of truth data set across all your tools to do analytics with SQL, but to do ML with Metaflow and Python libraries or Spark, to do experimentation analysis, and you don't want to have to make copies of that stuff. So that's really the power of Iceberg.
Fantastic. And I love that you framed it in terms of, connecting data upstream to business value and business outcomes. So maybe we can start at a high level, and you can tell me, when we're talking about the use of data to connect it to business outcomes, what type of business outcomes are we talking about?
Yeah, I think that's really where people are starting to come to the realization of, hey, we collect all this data and we put it in a lake, or we put it in a warehouse, and we were supposed to get value out of the other side, and that didn't always happen. It doesn't happen automatically, turns out. There are lots of different ways that you can get value out of data that you're collecting and processing. But there's because there's so many different ways, there's lots of different areas of the business and skill sets and tools that come to bear. So it can be used to optimize your marketing campaigns. It can be used to run A/B experiments on your product. It can be used to build personalization algorithms for your videos, like Netflix recommendation algorithms. It can be used to build large language models if that's what you want to do with them, right? LLMs. So I think the place where people get stuck is that that's a bit overwhelming. There's so many different things that you can do to get business value. But how do you actually get to them? And how do you do so efficiently? And so I think it really is, start with one thing you want to do, one thing you want to accomplish, make sure that works really well, but design that in a way that when you add on the next use case, then the next data product you're going to build, the next business value you're going to unlock, that you can do so with reusing as much of that original architecture as possible. Right. And that's kind of where we get to this, all the open sources, things like Iceberg. It's like, okay, well, if I had an end-to-end from data collection all the way through, recommendation algorithm, personalization for my product, that's great. What if I now want to take that same data and just do high-level dashboards for my executives? Well, I should be able to reuse 90% of that stack and just maybe just put the dashboard on the end of it. So I think the key is identifying all the different areas that you can provide value, and then how do you reuse as much of your architecture and engineering efforts as possible, so you're not having to reinvent the wheel every time.
Absolutely. So, I mean, something I'm really hearing in there, which I think is super important, is that as much as possible, we want to have the same single source of truth as data to serve all our data needs in terms of whether it's experimentation, machine learning, executive dashboards, exploratory data analysis, ML in production, whatever it may be.
Yeah, absolutely. And I think that historically has been not really technically feasible, and maybe only accessible to companies like Netflix and Apple's, et cetera, that could invest a lot of engineering effort into building these single source of truth systems. But more and more as these open source projects mature, as vendors and commercial products emerge around them, that architecture becomes available to the vast majority of companies, and it's a very powerful setup ultimately.
Great. And we've got a wonderful small Netflix fan club emerging in the chat. Carol has said Netflix has one of the biggest and most robust infra for data. They have a great blog post about it too. And Nick Salerni has chimed in and said they most definitely do. Big kudos to their efforts to open source a lot of it also. So that's really, really cool.
That was like, I was so glad to be at Netflix. And one of the reasons was like their big investments in open source. And for me in my career, it was great. I got exposure to all these open source technologies and got to become an expert in some that aren't that useful, like Apache Pig, which isn't super valuable anymore, although we used it at Netflix a ton early on. But a Spark and Trino, a Parquet file formats, things like Apache Iceberg, Metaflow. So it's great that Netflix both invests in that, invests engineering in that, and it also gives back to those open source projects. If you ask my co-founder Ryan Blue, like why did they open source Iceberg from Netflix, he'll actually tell you that it was very selfish on the part of him and Netflix, in the sense that we built it at Netflix and it was great, but we didn't want to be on the hook internally at Netflix for continuing to keep all the integrations up to date and to add new integrations for new compute engines. Like, okay, it works for Spark and it works for Trino, but what about Druid or Metaflow or other things that want to use this data? We could build all those integrations ourselves and maintain them, but it was a much better thing to share with the community and then get the whole community involved in building new connectivity and maintaining as these versions of these things increase. Like, there's a lot of entropy in the data world. As people know, there's a zillion tools, and it does take a village to keep everything going in the right direction.
Absolutely. And I think this framing of, a suite of open source tools dovetails really nicely into what I wanted to talk about next. I mean, a lot of our audience are data scientists, machine learning engineers who are really thinking about what tools to adopt. And as you know, there's a huge proliferation of tools in a variety of forms. And there are, we can classify them in a number of ways, but one way to slice it is that we have, a bunch of single large proprietary platforms, and we also have a tool chain of open source tools that's possible. So I suppose I'm interested in, for someone who wants to adopt new technologies, why and maybe when is a tool chain of open source tools a more appropriate choice for your data stack than a single proprietary platform?
Yeah, that's a great question, and one that we definitely wrestle with. I think first is to understand, like, what are the trade-offs between that decision. And historically, it was a bit more straightforward. You were either fully in a proprietary platform like Oracle or Teradata, right? And it was all of your compute, as all of your storage. You could only do what those systems allowed you to do, and that was it. And so it was either that, or if you could go the open source route, fine, but it was a choose your own adventure. You had to take all these technologies, you had to stitch them together yourself, you had to glue them together with all the infrastructure, and you needed a lot of engineering resources to do that. So it was expensive to go that route, but you gained a lot of power and flexibility and long-term cost mechanics, because you weren't tied into expensive platform licensing fees. And that was Netflix's case. Like, we were a big Teradata shop early on, and it got incredibly expensive, and you could really only do SQL analytics. And what about all the other things we wanted to do? And we moved to this open stack, but it was, painful and a long engineering process. And now we're in this world where, we have more, even the proprietary systems have more optionality and more integration. So you can take something like Snowflake, and that actually has support for Iceberg storage tables. So you can use, that compute and combine it with open source storage, or Databricks has something similar with their Delta Lake product. Even Microsoft getting in on it, they have their whole Fabric product now, right, which just came out, which is kind of this architecture backed by OneLake, which is Delta Lake open table format underneath the covers, which means you can plug in some different tools to it. So we're operating in more of a hybrid world than we were, but I still think the choice ultimately comes down to is optionality, right? If you're going to go the open source route, you just are always going to have a lot more choices at your disposal. You're not going to be locked into choices given to you by a vertical proprietary sort of stack. And the question then becomes is that optionality that you gain worth it for what will likely be still, even in today, which has gotten a lot better, but still a little bit more work stitching these things together. And the open source tools and ecosystems, right, what Tabular is doing and Outerbounds, and making it easier to use those tools together, and so on and so forth, trying to make that story better. But it really does come down to that. Do you want the sort of ease of use, integrated platform, everything works relatively well together, but you're limited in your choices and you're kind of tied to their cost model? So sometimes it can be a cost driver. Or do you want to go the open route, open stack, have multiple tools, have a lot more optionality, more control over costs, but with the challenges that come through integrating multiple tools? So trade-offs to be had for sure. I think the big one that maybe people overlook is is the next decision. So like you're making this decision maybe in this moment, but what about next year when the next new tool comes along, right? Like how quickly can you integrate that? And are you going to fall behind competitors because they're able to integrate a new technology? They're able to integrate, generative AI tools that into their tool chain, and you can't because you're still waiting for your vendor to provide something in that space. And making sure that you think about that future-proofing aspect. Like the landscape is changing so fast. I think that optionality is also about speed and agility and time to market.
Absolutely. And this is something that I would have even said 5 years ago, right? That a lot of, and I've experienced this, a lot of data scientists I know have experienced this, where when you're locked into a proprietary platform, you may not have access to the most recent bleeding edge version of PyTorch, for example, right? Just plucking something out. And that was a challenge several years ago, as I've said. But now, as you mentioned, with all the generative AI tools, if you're locked into something and you don't have access to this entire new suite of parts of the tool chain, that can be, a strategic disadvantage, right?
Absolutely. So there's that on the technology front, and then there's the ecosystem, which is both as individual in this space, right? I benefited a ton from my exposure and then experience and now sort of expertise in open source technologies. Had I been somewhere like early in my career, I was at Lockheed, where it was like I was doing all Microsoft stuff, and I knew Microsoft SQL really well, but I didn't know any of the other tools outside of the Microsoft stack. That made me much less valuable on the open market as an engineer. I just had a narrow field of view and a narrow skill set. And similarly, companies who are only using a single technology, they can only hire people who know that tech stack, and their pool that they can choose from isn't as broad. And engineers who want to get exposure to open source and broaden their skill sets aren't going to be as excited about working in a place that's in a single stack. So. And like those are all secondary concerns, but very real concerns. Like Netflix was able to attract, I think, a lot of the top engineering talent because people knew they could go there and always be working on the latest, cool technologies and open source technologies, et cetera.
Absolutely. We have a bunch of really interesting questions. Some are Iceberg specific that I want to get to once we kind of dive deeper into Iceberg. But before that, we have a super relevant question from Alex Leith, who actually I know from when I worked on Dask. He works in geospatial, kind of large scale geospatial stuff in Tasmania. But Alex asks, have you seen Pushback? And I think he's referring for your time at Netflix, but also anything beyond that. Have you seen Pushback on open source from decision makers? In Alex's industry, geospatial, there's a whole tension between commercial off the shelf and open source. And Alex is interested if it's the same in web scale orgs or anything else you've seen.
Yeah, I think you have that same tension in any industry, right? Open source versus commercial, and like now the world's even muddier with these sort of hybrid offerings like Outerbounds or Tabular, where there's a commercial entity there, but it's all based around open source, like core open source stuff, or Confluent and Kafka is another good example. And so there's a whole spectrum there. There's definitely tensions between decision makers and engineers. And I think there's good arguments all around it. I don't think there's a right answer to these things. I think those tensions are actually probably healthy because they force you to evaluate the trade-offs and what they mean for your business in your situation. So you have to, the answer of it depends, while is incredibly generic and probably tiresome, is it depends. I think it's the right answer. And those tensions I think are healthy, and organizations just have to, as long as they're willing to be open about the trade-offs and make informed decisions and not just say like, oh, well, I'll never use open source, or I only use open source, or I only use commercial. Any absolute position is probably naive.
Absolutely. And it's also worth mentioning that the hybrid nature of open source and managed services and productization of open source and vendors based around open source also does support open source in terms of de-risking for adopters, right? So one example that I'll give, as I said, I worked on Dask and worked at a company Coiled that supported Dask. And when a lot of people I know were figuring out whether to go with Dask or Spark early on, the existence of Databricks, pre-Coiled and pre-company supporting Dask, was something which was really important. Having having a having a phone number to call when stuff doesn't work, is incredibly important.
Absolutely. If you're trying to run a business, right, and there's not somebody you can call when something's broken, and you're just on your own, that's a very scary place to be, especially with something that's going to be core to your business. So I think having commercial entities around open source is ultimately a very healthy thing, because it's like, well, what happens if this open source project, dries up tomorrow, the community goes away, and we're left holding the bag? Nobody wanted that, and that happened a number of times early in the sort of open source software world. And I think we're seeing okay, once you get some commercial backing around this, that's good to de-risk companies, it de-risks adoption. It also provides resourcing to continue to develop the project, right? Because open source otherwise is sort of, hopefully big companies and hopefully maybe individuals on their free time, but that's a lot to ask if you're going to bet commercial money around it. But when you get, an Outerbounds or a Tabular or a Confluent or a Coiled, in Das's case, then there's real dollars there that are being put into the project, make sure that it gets maintained, make sure that it gets bug fixed, make sure the vulnerabilities are dealt with, right? Those kinds of things that enterprises really care about. So I think that's all a good thing. And then the question becomes, does it still maintain that open source community where you get contributions from lots of different people, where it's not being totally driven by one entity, and then you lose a lot of the value about something being open source, because then it's just open code, which is a different kind of thing, right? Like, you can read the code, but you really can't drive anything about the project. That loses a lot of the value of open source and community-driven efforts. So, that balance has to be there.
Yeah, and to be clear, open source is a very broad church, so to speak, right? Open code is very different to open governance. TensorFlow, for example, is open source, of course, but it's a very different model of governance than what we think of when we think about. It's company driven, right?
Yeah,
so this is really exciting. I'm really interested. So once we've decided that we want to start thinking about a tool chain of open source tools for the data stack and tying that to machine learning and business outcomes at the end, what then can what is the tool set? What does it look like? How can we think about it?
Yeah. I think, you can look at the broad, data infrastructure diagrams, and they all have similar componentry, right? And so you've got something to get data into some sort of storage system. So ingestion of some kind, that can be something like streaming, and if open source, obviously Kafka comes to mind, but there are now other good open source alternatives to that as well. As well as maybe you need to take your transactional systems and move that data in, and there's open source things there like Debezium or something for doing sort of change data capture kind of thing. So okay, we're going to move this data, and there's real reasons to get data out of transactional systems, out of streams, into more long-term storage, and just sets up a lot better for a lot of the downstream data use cases, analytics, ML, et cetera. There are good use cases for streaming data as well, when I'm going to sidebar that, because that's a whole different conversation we could have on a different day. So okay, you got to get that data in, you got to do ingestion. Then there's storage, right? And then so that's where you've got things like Apache Iceberg, Delta Lake, Apache Hoodie. These are the sort of the common open table formats. That gives you, these nice storage properties about, I have schema evolution, I can safely do transactions on this stuff, things that you really need if you're going to build enterprise data products. And after that, you get to the consumption layers, right? So this is okay. What's my ML toolchain? I have model training and serving and versioning, all the things that Metaflow plays in. You've got other maybe just big ETL type processes, something that Spark has really kind of dominated the market for a long time, of just doing transformation at scale. And then you've got analytic workloads, ad hoc ML workloads, something like Trino has sort of been the dominant player for a while. There are other open source tools as well. And then, serving dashboards, and there's all kinds of open source visualization tools, notebooks, Jupyter, and other open source notebook tools. So there's a very healthy suite of tools you can use to cover almost all the bases. And they're in those big areas, I would say. And then I think the one bit, and hopefully it's something that we can get into a little bit, that's been historically missing, and I think still is, at least there isn't a good open source alternative, is how do we do governance across that whole thing? And I should say that there are open source solutions for what I'll call federated data cataloging. Like, let me just collect all these data assets and put them somewhere where I can search through them and tag them and document them. Those are things like Data Hub is a good open source thing that came out of LinkedIn, or Adminson as well, which came out of, I think, Lyft. I can't recall. Right,
Yep,
some good open source tools there. But then the piece that's like to do this at scale in an enterprise is how we're going to do security as like the governance is a big space, but in particular, how are we going to secure this data and make sure that we can comply with data regulations, like there's all the data privacy legislation and just like consumer awareness on data privacy, which is really healthy and important. This is kind of new, and juxtaposing that with this open source toolchain, that's where sort of the rubber meets the road for enterprises, and how do we actually do those two things well together? And I think that's still a bit of an unsolved question. There are certainly vendor solutions for this, something that the Tabular plays in, but that's a tricky bit.
Right, and I do want to kind of drill down soon into the data governance concerns after we talk some more about security and regulatory requirements. Also, I'm interested in, I mean, you do work on Iceberg, so I'm interested in that. That's a really nice kind of schematic of the tool chain with tools such as Iceberg in the middle. I'm interested in why Iceberg? Why would people adopt a tool like Iceberg? And maybe speaking to where it sits in the tool chain as well, all the way through to being able to have a single source of truth of the same data for all of your downstream needs, which I know is a really important concern for all of you.
Yeah, I mean, I think that's the primary one. But then, like, why Iceberg?
I'm sorry, I answered my own question there.
No, that's okay. Like, I think that's the most important one. And then, like, maybe why Iceberg specifically versus other choices you might have. And I think it's also why open, like why choose an open format for that, and then across the open formats, then why Iceberg. So I'll try and cover both of those, at least in my opinion. So I think why open in particular is so important at that storage layer, at that central piece, is it is because it's at the middle, right? Like you have to bring data into it, you have to get data out of it in multiple different ways. And so the interoperability, in order to have the story where we can have a single source of truth, in order for that to work, interoperability is the number one concern. It has to be able to work well with all the other tools in the ecosystem, open tools and commercial vendor tools, right? It has to also work with Snowflake and Fivetran. So having an open standard is really, really important. And so you see things, anything in the tech space and even non-tech spaces where interoperability is the key component, open standards tend to be the ones that win out. Something that everybody in the ecosystem can point at and rally around and say, like, yes, we all will benefit by contributing to this open standard. Like that, to get all these different parties to agree on something is hard, but becomes the big unlock. Like, okay, we have an open standard here that we can all invest in, and we can all trust that it's not going to go in a direction that's bad for our company or our product. And so that's really, really important. And that's why I think you see the open table formats being at the center of that story. And then why Iceberg, and it's related to that, is if you're going to have an open standard, and it has to be something that many, many different companies, open source and commercial companies, can invest in and trust, it has to be something that's very much community driven, right? That everybody's voices have a chance to be heard, and there is a good governance. In this case, like it's an Apache project, but there has to be a really healthy governance model to make sure that people feel that they can contribute effectively, and then they can build stuff on top of it and not have it ripped off from underneath them 6 months down the line. So that's where I think Iceberg really shines. It has an incredibly healthy community, industry players, Netflix, Apple, LinkedIn, Airbnb, etc., as well as commercial interests, Snowflake and Cloudera and IBM, the clouds as well, AWS and Google. So you've got all these parties that have all said, yeah, this is an open standard. We can all invest in this thing. Nobody controls it, right? It's got a good governance model. And we can build the future on top of this open standard because it's a win for everybody to this architecture of single source of truth, which I think is what the marketplace really, really wants. So that's how I see why Iceberg. There's all the technical reasons, and Iceberg is an amazing like technology in and of itself. But I think the real reasons are actually non-technical reasons of why Iceberg.
Great. We've got a question from Nick Salerni. Nick's curious as your views on migration to Iceberg from other potentially legacy solutions. So specifically coming from the angle of engineering effort for small and large teams to migrate.
Yep. So, data migrations are the bane of everybody's existence, mine included. Most people coming to Iceberg because it is ultimately Parquet data files underneath the covers, right, are usually coming from some sort of Parquet-based storage or like Hive, but maybe you're coming from Snowflake or some proprietary storage system as well. And there's a couple things there. Since it is based on top of Parquet, the migration path is mostly about building the Iceberg metadata, the table metadata, which turns it into a really usable interactive table on top of existing Parquet files. So that's the simplest thing. You can actually do this migration almost in place, where you're just reusing your Parquet data files and building metadata on top. Otherwise, the migration to Iceberg looks like it does in kind of any other data warehouse or database migration, where you're sort of select star from old, insert into new. And that obviously works in the Iceberg case, just like it does in any database. But there is a slightly cleaner path if you're coming from an existing Parquet or Orc-based data warehouse. There's some streamlines into that story, and that's like the Netflix case, and Apple similarly. Yeah.
Great. And just quickly, if for those who haven't used Iceberg before and want to find out more, where can they do that?
Yeah, obviously, the Iceberg Apache website is a great place to go. Documentation there. The very front page of that has also how to get into the Slack community. The Iceberg Slack community I think we just recently crossed 3,000 users in there, and it's awesome. An incredibly active place for both newcomers asking, intro questions, as well as experts and experts giving answers. And so again, community aspect is really healthy there. And obviously, like if you want the easiest button, Tabular is a great place to start. We have a free tier. You can go there and click sign up, and you can get started with Iceberg tables, in a matter of minutes. So I'd be remiss if I didn't at least plug that a little bit.
Absolutely. Great. So I've actually shared the links in the chat to both the Apache Iceberg page and to tabular.io as well.
Awesome. Thank you.
So we've mentioned a bit around governance, which we'll get to. Before that, though, I'm interested, especially in kind of a changing landscape of security and regulatory requirements, how you can make sure that your data and pipelines meet security and regulatory requirements.
Yeah, so I think this is a bit of a mindset shift architecturally, right? As somebody who's like been working in data infrastructure and data architecture for a long time, in a world where your compute and your storage were bundled together, you could sort of secure that, and you do that in one system. Like in Teradata, you set up your roles and your permissions, and that was how people got access to data, and you could sort of go for this least privileged access concepts. And it was cumbersome still, because like, how do you get access to data that you need access to? You have to go through, request flows and approvals, et cetera. And, but you could lock it down, and then you could audit it, right? You had an audit trail of all the activity against the data, who had access to what, and when they got access, et cetera. And that was good from a security perspective. And then when you want to do things like governance, like saying, hey, right to be forgotten type of rules, if, customer raised their hand and said, hey, you no longer can have my data, you'd find their customer ID, you'd go through your warehouse and delete everything with ID equals JSON, and you could be relatively sure that you were meeting the requirements. That became really, really messy when we started collecting data in these open formats, right? Especially pre-Iceberg, but even in Iceberg, if you're doing this on top of S3 or something, how do you effectively do security, especially when you've got multiple different ways to access data? If we're in this architecture, which we all want, which is single source of truth, and read it from multiple different tools, how do we successfully lock that down or even know who has access to what? How do we audit it? Who's accessing the data? Like really difficult stuff. I don't think we have, great open source solutions yet. At least at Tabular, we've built something where the idea is to move that security from being in the compute layer, in the tool that's asking the data, and put it on the actual data itself, right? So this is like the distributed cloud version of how your file system on your laptop works, right? It's like you have documents on your hard drive, and certain users who have access to your laptop have access to those documents. So it's not that you say Microsoft Word has access to this doc, but the text editor doesn't. Like that's not how it works, right? Like you secure the file, and then all that access goes through the applications, but the file is ultimately a thing that's secured, not the application. And so, same thing now. We move to these distributed data architectures. We need to start to move the security layer down to the physical storage, and make those compute layers basically come with some sort of authentication and authorization to the storage, and say like, hey, I'm Jason. Here's my authorization that says I should have read access to this data. Can you please let me in, right? And no matter if I'm coming from a Python process, or I'm coming from a Spark job, or I'm coming from a Trino query, like that same exchange has to happen. So I think that's where we're going to move to if we're going to be successful in this architecture. And it's definitely a challenge, and it's definitely a shift. But that would get us to at least security, and then we can audit it, right? If all that security is happening at that storage layer, we can get back to getting a nice clean audit. Then there's the secondary concerns about what about GDPR and those kinds of things when customers say, like, hey, forget that you have data on me. And that's yet another suite of capabilities that we need to build out in this architecture. It's things like having really good lineage, right? Where did all these customer records go? How many different tables did they show up in? How do I actually effectively find all that data? And then how do I remove it efficiently when I have these column narrow file formats? So the data is all organized to do bulk analytics, and now I'm trying to do record level, inserts and deletes and things of the nature. Difficult stuff to do. And Iceberg and all the other table formats have added capabilities to do like record level operations. But doing all that efficiently at scale in an enterprise type of environment, and keeping track and being able to prove to some auditor or regulator that you've complied, I think we're still early stages of doing that kind of stuff.
And how do we even think about this when, we have data begetting new data? So, with feature stores and metric stores and all of these different types of things, and, people doing machine learning, doing transformations and that type of stuff, and having that stored in a variety of different places.
I think these are great questions. I think this is where, the regulations are always going to be behind the technology. I mean, what does it mean if you take all of my search history and you turn that into some embedding and you use it in a model, and then I tell you, hey, you need to forget about me. Okay, you can drop the records in my search history, maybe, but you use all that data to build your model. Is that up for grabs? In these large language models that have been built on, a corpus of text that have been, did these people give permission for that to be used in the model? These is like uncharted territory. So regulators are going to have a field day trying to keep up, I'm sure. And then, what can the architectures and platforms and technologies do to help make sure that we can still leverage our data and build these super valuable data products, but do it in a way that meets the governance requirements in a fast changing world. And so that's sort of like that, thinking about that future proofing of your architecture. You should think about some of those future problems and how you might solve them with whatever you're building today, because those problems are definitely going to come your way at some point, and we got to deal with this. I think, again, it goes back to being able to have really good lineage and understand how these data products are built, how they're connected, the connectivity across all these things, and then ways that we can effectively both do the governance and then audit it and make sure that we're meeting requirements.
Yeah. And I'm glad you mentioned the existence of models that are trained on data as well. Large language models are one family, right? But I don't know whether this has actually occurred in any large scale way, but there's a whole fascinating area of research on extraction attacks, of taking models and being able to extract training data from the models, right? Which, is pretty pretty out there.
It is, and it's a new vector of attack. And I think, yeah, we're at just the very early stages of the sophistication here. But I think we'll see. Time will tell. But yeah, thinking through these future states should, at least in like, even if you can't predict exactly what's going to happen, as good architects, we should try and anticipate these future requirements and give ourselves outs, right? Our architecture, at least technical architecture, is about having two-way doors and optionality, right? You can give yourself an out. Don't design yourself into corners that you can't get out of, or will be big migration efforts, big tech debt holes that you've created for yourself or your company down the line because you didn't think about possible outcomes.
For sure. Carol Willing has just noted in the chat that, of course, these are hard problems from an open science research standpoint, more generally as well.
Yeah, I agree. Super hard problems. And I think that means we'll all have jobs for the next handful of years trying to figure them out. I'm excited for it. I think, we'll find a way to find a balance between the power and the value of these things, and hopefully balance that with doing it responsibly, I hope.
Absolutely. This leads really nicely into the conversation I was hoping to have around data governance, and what you all are up to at Tabular as well. But why is data governance important? Why do we need to think about it, and what type of tooling exists around it?
Yeah, I think it's important for all the reasons that we've just talked about. Beyond just like, hey, we need to comply with government rules and we just stay out of lawsuits, which is a really big risk for enterprises. Like we've all seen the headlines. There's big dollars at play for violating regulations. So you need to be able to comply with that stuff, and it's only going to get harder and more complicated as we go forward. But beyond that, it's just in order to make sure that you can get value out of your data products and that you trust. I think trust is a big part of it. Not only trust of your consumers or data you're collecting, but just internally, your users being able to trust the data that they're using, right? So governance is a lot about trust.
Yeah, if I'm using a feature from a feature store to, deliver value or try to say something about ground truth about our business, I want to make sure that I know exactly how the generator process for that data, right?
Absolutely, like provenance, this is like in science, right? You need to be able to know like where did this data come from? Is this reproducible? This results, right? And in order to do that, it's about trust and about being able to walk the chain back and say, where does this data come from? What kind of transformations did it go through? Has it changed in the last time I looked at it?
Yep.
Who is capable of changing it, right? Again, going back to security and access things, all that stuff, it matters. And it's all around this concept of trust, trusting answers, trusting models, reproducibility, right? That's a big part of it.
Carol Willing has a great general question. How as a company do you instill trust?
Yes. Back to the human aspects. We've talked more about humans than technology. This is probably a good thing, Hugo. Yeah, I mean, trust is still a human thing. All the tools and technologies and infrastructure in the world is not going to get you trust. So trust is built in a way, in data with data, in ways it's built across all humans. It's we're getting to philosophical stuff now, and stuff that I'm probably not best to speak to, but my experience, it's been, does this thing do what it says it's going to do, right? This are the integrity pieces, both as humans and technology. If you say it's going to do X, does it actually do X reliably, right? Or does it do it X sometimes and Y other times? That doesn't help. Is it available? So availability is a big part of it, right? If is this data set like, can I actually use it when I need to, or is it like, oh well, maybe on Mondays it's working, but on Tuesdays the data pipeline broke and now we can't use it anymore, or it's stale, or any of these things, right? So yeah, repeatability, availability, those are the trust factors, and then ultimately, still it's a human to human thing more than anything that I've seen. In like Netflix, you trusted data because you trusted the team that produced it more than anything else.
Yep. So now we know a lot about why data governance is important. What type of tooling exists around it?
Yeah, there's lots of different tooling. Governance is such a big space, right? I think you've got tools that all cover bits and pieces, and then there's lots of overlap. Like most data, like most data tools, there's the thing it was designed to do, and then there's the spaces it bleeds into around the thing it was designed to do. So the most basic piece is just do I have a catalog of all the data assets that exist in my organization, right? Transactional, streams, analytic data sets, features, models, right? There's dashboards. There's so many different types of resources. I mean, can I just get a listing of all those things? Do I know it all exists out there? And so I call those, they're data catalogs or federated data catalogs. And, these are the tools like Data Hub and Adminson, et cetera. And then there is, and hopefully I'm gonna assume that those also come with some amount of documentation about what they are. So I can list them, but I can also get some information about what this thing is. The next set of sort of that is, well, where did this come from? So this gets into like the lineage aspects. I think that's the next sort of important piece of like, okay, I have a listing of things, kind of know what they are. How are they related? Like, what's the sort of the graph that connects all these data resources? So we often call that lineage, but yeah, it's some sort of graph that says like, here's how these things are connected, and that's cool. And then you just sort of keep layering on that. The next thing would be, all right, well, what's responsible for actually making those connections? There's SQL jobs or ETL things or models that are being trained, right? There's all kinds of different ways these things are connected. What are those things? And where do I find, the business logic behind that? Where's the code or SQL or model that actually makes that connection? And what's the governance around that thing? Is it version controlled, right? Like who created it? Who's changed it recently? And now we start to get into the people aspect of this, because usually at some point when you draw a connection between two resources, there's some process there that some human ultimately created it and put into play. Maybe now in the future will be non-humans too, but even then you want to know what is responsible for drawing this connection, and what's the logic that's being imbued into that. And then there's like the security throughout this entire thing, right? All of those nodes and edges in this larger graph have security aspects to them, like who can make changes to stuff, who can look at these data sets, who can make changes to them, who can look at the processes that are generating the connections, who can change the logic in those connections, right? Because you change the logic, you change the result. So there's like, who can do this stuff? And then, as I mentioned before, all the auditability there. Like, okay, well, who can? Great. Then who actually did? Like, who actually made these changes? When was the last time it changed? How stale or fresh are these things? All that, I think, is part of the governance story, and it's an overlapping suite of tools today. Even if you are in one of these like pretty vertically integrated proprietary platforms, it's unlikely you're not using some additional tools to cover the gaps, because there's nothing that sort of does all of it today.
And how do you think about data governance at Tabular, and what do you do in the space?
Yeah, so the place that we play directly is in that security of tables, right? So like we are all about Iceberg tables at Tabular, and we're all about securing those tables, as I mentioned before, regardless of how you want to use them, no matter what tools you're using to sort of look at the data or write the data in. We want to provide security around that resource. So that's like the big governance space, especially a pretty narrow area. It's like, well, across all the resource types, we're only talking about your analytic tables, your Iceberg tables. And then even then, we're really only talking about maybe documentation and security. Like that's kind of the extent of where our tool ends. We're not talking about lineage. We're not talking about the jobs that are necessarily running around those tables and how those things are all interconnected, at least today, right? Like we're pretty focused on that basic part. That basic part is hard enough. I imagine we'll continue to grow into more of those spaces. But today we're really focused on delivering discoverability of your Iceberg tables, documentation around those things, and then securing those things effectively.
Awesome. And so we've got a few minutes left, and earlier we talked about why Iceberg might be a good option, kind of from the organizational and cultural and human point of view. We didn't get too technical, but maybe we could drill down just technically a bit into part of the value prop of Iceberg and why data scientists might want to start thinking about it more concretely.
Yeah, this is perfect. And this is where I can hopefully make some connections with Metaflow and Outerbounds. So
Awesome.
yeah, like if you're a data scientist, why should you care about Iceberg, or why should you think about using it? Well, first of all, like hopefully you don't have to think about it too hard and it just sort of works. But why is it good? Like I'll juxtapose that versus what I see a fair amount of in the data science world is, hey, I have these Parquet files on S3. So let me just use that as the alternate condition. Like I have Iceberg tables or I have Parquet files on S3. And why do I think Iceberg tables are preferred? The first one is just that you get to address a data set as just that, a data set with the schema. And you don't have to be concerned about the intricacies of Parquet or Orc or any of these like file formats. So up-level this a bit as a data scientist. Again, I want to focus on building models or doing data science. I don't want to have to be an expert on Parquet or Orc file formats, or how having 1,000 of these things in 12 partitions is different than having 10 of these things in 5 partitions, and all those nitty-gritty details. Like we really don't think data scientists have to worry about that kind of stuff. They just want to get the data in to their environment, probably a Python environment, right? And then go to work doing their data science. And then hopefully be able to store the results of that somewhere that's not ephemeral, right? Like persist the results of their work. So persisting back into Iceberg tables, I think, is also a nice thing, because now you've just made it that much easier for anybody else in the ecosystem, other data scientists, but also analysts or whoever else to take advantage of that result that you produced. So, up leveling from files to tables, I think is a big part of why I think it's good for data scientists. As well as, your source data is probably not static, right? There's probably some process that's feeding it and constantly updating it. And you don't, as a data scientist, really want to have to think too much about that either, right? Like just give me the most recent thing and I just want that. I don't, why is this data all wrong? Oh, you have to talk to the data engineer and they say, oh, well, yeah, that data had bad data quality. I restated all that. And here's the new version. And you were working on these old Parquet files. Like you want to avoid those kinds of situations. Definitely do happen. And then so that's like the first one. Like, let's just talk about tables instead of files. That's a big win for interoperability for yourself and your ecosystem. And then the second one, which may be more relevant for data science, goes back to this reproducibility bit. And this is where Iceberg is really fantastic for data science use cases, because every change that is made to an Iceberg table results in an immutable snapshot of that data set, right? So as a data scientist, I can say, okay, I'm training this model against these very specific versions of my underlying source data, and I produce this specific version of output, right? Whatever that might be. And then you can go back and you can reproduce that regardless of how those data sets may have been changing since you last, did your training. You can go back and reproduce that. And if you want to have a new version of your model, you think it's better, you can actually prove that against the original data that your original model was trained against, right? So like it takes variables out of the equation. And as scientists, we like this, right? We want to fix as many things in the world as we can. We like reproducibility. We want to be able to know that our change was causal, right? And not just because the data had drifted since we last ran the model. So having those immutable snapshots of history that you get with Iceberg tables, but you can't get in Hive style tables or even other table formats, is super valuable for data science workloads.
Amazing. Carol's commented immutable for the win. And as you know, at Metaflow and Outerbounds, especially when it comes to models and all artifacts that you pass through machine learning pipelines, the versioning story is incredibly important to us as well, and being able to have access to these snapshots. The first time I heard about Metaflow actually was on a podcast that Savin Goyle, who is our CTO, was on, and the host said it reminded him of when you save video games and having snapshots of video games, and that's an analogy that I really like.
Yeah, it's that I want that save point. I want to go back to that state of the world.
Exactly.
Right? having that immutable state is so important. And Metaflow does that for your pipelines, right? And Iceberg does that for your source data. So if you combine those two things, you really have a completely reproducible experiment ultimately.
So we have another nice question in the chat from Eddie that ties this data story in with the ML story. So Eddie is asking, does Tabular Iceberg interact with ML model features or only the source data sets they are derived from? Are ML features just another data table to Iceberg or something different?
Yeah, I'd say ML features are just another table to Iceberg, right? Like that's a data set with schema and records, and so it would treat it like any other data set. There's nothing special about ML features versus signups as far as Iceberg data sets are concerned. It's pretty generic in that sense.
Great. Well, this has been an amazing conversation. Thank you for your time and expertise, Jason. And thanks everyone for your time and attention and joining and engaging so much in the chat. I'm gonna, for the few questions we didn't get to, I'm gonna post a link to our Slack once again in the chat. We've also linked to Apache Iceberg and Tabular for people who wanted to get started. I was wondering if there's anything else you wanted to let people know, Jason, or any other ways to engage with the community?
No, I think that's great, and I think we're planning on putting out some blog content that shows Metaflow plus Iceberg and how you connect those two technologies together. Speaking of making this ecosystem super interoperable, I've seen some demos of how it all goes together, and it's super slick. And so look out for that content as well.
Yeah, definitely. Because getting these different parts of the stack working nicely and showing content around that, around the interoperability is so important to us. And definitely your feedback and how useful you find it would be great as well. So thanks once again, everyone, for joining. And thanks once again, Jason. Really appreciate you.
Thank you for having me on. Thank you to everyone who let me rant about data for an hour. It's what I enjoy doing the most. So yeah, appreciate the time, Hugo. Very much appreciate it.
And scene.